NASA just made public a series of surprising observations that have utterly rocked the scientific community's long-standing beliefs regarding Neptune. Usually eclipsed by its more theatric planetary companions, Jupiter and its massive storms and Saturn and its famous rings, Neptune has long been regarded as a cold, unchanging, and fairly subdued ice giant. It sits almost 3 billion miles from the Sun, and Neptune was thought to be reasonably well known, a high-ice planet, a hydrogen-helium atmosphere, and fiercely, if predictable, weathered. That thinking has now been fundamentally undermined. New data from both Earth-based telescopes and deep space observatories have painted a radically different picture of Neptune, one that reveals a planet far more dynamic, volatile, and mysterious than previously imagined. The first major revelation came from observations of Neptune's magnetic field. By combining data from the Hubble Space Telescope, the Chandra X-ray Observatory, and high-resolution radio spectrometry instruments, scientists detected alarming inconsistencies in the planet's magnetic topology. Although it was previously known that Neptune's magnetic field is tilted roughly 47 degrees from the planet's rotation axis, contrary to Earth's better-aligned magnetic field, what astounded scientists was that the tilt of this field is apparently shifting rapidly. In a mere few years, Neptune's magnetic field has measurably shifted, displaying bizarre and erratic distortions. Such real-time fluctuation implies a stormy, unstable interior, the opposite of early models that depicted Neptune's core as comparatively inert. This magnetic peculiarity was compounded by unprecedented atmospheric activity. Neptune has long been known to produce monstrous storms, such as the Great Dark Spot, a hurricane-sized vortex of clouds and wind. Recent observations, however, detected outbursts of infrared and ultraviolet radiation in fast, explosive bursts. These bursts imply high-energy activity is occurring deep within Neptune's cloud levels, activity much greater and more frequent than anticipated. This previously witnessed cold, quiet planet now seems to be turbulent with internal energies, fueling an anarchic, high-pressure system. Even more interesting is the seeming connection between Neptune's magnetic abnormalities and these atmospheric bursts. In another instance, a 16-hour series of bursts of ultraviolet light timed closely with the fluctuations in the planet's magnetic field, prompting scientists to a revolutionary hypothesis. Neptune might have internal processes more like active terrestrial planets, even stellar events, than an ice giant. This would leave open the possibility that Neptune's core is not as solid or frozen as thought to be. Rather, it may be made of exotic matter, such as superionic water, metallic hydrogen, or exotic ice phases, that behave in ways that produce erratic electromagnetic and thermodynamic activity. Complicating the mystery, Neptune's upper atmosphere has experienced a sudden and mysterious cooling. Stratospheric temperatures plummeted by almost 10 degrees Celsius over a period of only 2 Earth years. This defies earlier models, which had forecast a gradual, incremental warming trend. Seasonal variation and solar input were unable to explain such a sudden change. Some researchers now suspect that Neptune might be experiencing a planetary scale change, a systemic change within its internal or atmospheric dynamics. Ideas have been proposed, ranging from magnetic pole reversals to deep convection internal shifts, but none adequately account for all the anomalies seen. One of the most intriguing discoveries was made by NASA's examination of Neptune's gravitational field. Information uncovered anomalies suggestive of a gigantic, low-density area within the planet, possibly an airy area or inner void. This totally shatters the long-held paradigm that Neptune's interior is dense and homogeneous beneath its thick atmospheric cover. If Neptune really contains a hollowed area in its core, it would require a total overhaul of ice giant planetary formation models. Such a gap might be the product of a giant impact early in the planet's history, one capable of disturbing its internal layering but not powerful enough to shatter the planet. As these interior enigmas accumulated, so did interest in Neptune's thin but intriguing ring system. Traditionally viewed as stagnant, dusty residues of shattered moons or cometary fragments, Neptune's rings have been showing signs of motion and clumping lately. High-resolution imaging showed active processes taking place within the rings, possibly caused by gravitational resonances, shepherd moons, or internal dynamics. And even more chilling is that some of the changes happened too rapidly to be accounted for by standard Newtonian physics, suggesting varying gravitational forces possibly related to Neptune's fluctuating core or magnetic field. Next came the most strange revelation so far: brief outbursts of radio emissions never before seen from a body in the solar system. They were short-lived, lasting milliseconds, and unlike any natural phenomenon observed before. They were not like auroras, usually caused by solar-wind interaction. They seemed to be internally produced, almost as if a pulsing rhythm. They were compared to planetary heartbeats. Efforts to decipher them continue, but so far, they are unclassifiable. Others have suggested exotic causes, from resonant waves and superionic ice layers to transient plasma loops created in the field-soaked atmosphere. Every new anomaly contributes to the expanding understanding that Neptune is much more alien than was once imagined. What was previously considered a stagnant ice giant now looks and feels like a living, breathing world with reactive layers, complicated internal chemistry, and inexplicable electromagnetic activity. These discoveries have even stoked analogies with far-off exoplanets, namely hot Neptunes, which are close to their stars and have high-energy events like those now being observed on Neptune. Might our Neptune be the key to making sense of these mysterious, far-off worlds? If it is, research on it could provide groundbreaking information on the nature of planetary systems throughout the galaxy. The consequences of Neptune's actions extend beyond its own atmosphere. Astronomers are currently investigating if its dynamic nature might be impacting the Kuiper Belt, a huge area replete with icy bodies and dwarf planets that starts just beyond Neptune's orbit. A slight change in Neptune's magnetic field or gravity might, over time, skew the orbits of neighboring Kuiper Belt objects, KBOs. Indeed, there have already been observations of unusual orbital patterns by some KBOs, speculating that Neptune's effects are more dynamic and extensive than ever before conceived. Even the moon system of Neptune has not been left behind. Triton, the largest satellite of Neptune, always fascinated astronomers with its retrograde orbit and geysers expelling nitrogen ice. However, new scans of Triton's surface indicate recent alterations of structure, perhaps connected to Neptune's magnetic fluctuations. There is increasingly the suspicion that Neptune's internal evolution may be causing tidal or magnetic heating of Triton, quietly deforming its crust and interior. This suggests a fundamental, continuous interaction between planet and moon, a dance of forces going on right now in the outer solar system. These discoveries have profound consequences for planetary accretion theory. Traditional belief has been that the solar system evolved in a decently organized manner, with gas and dust coming together and eventually condensing into planets over millions of years. Neptune, which is far from the Sun, was thought to be made up of mostly ice and light gases, developing quietly in the cold outer environment. But the new observations paint a different picture, a one of violent effects, turbulent magnetic evolution, and exotic internal chemistry. The early solar system was possibly much more dynamic and violent than we had ever dreamed, and Neptune most likely took the worst of it. It is all part of a larger truth: the outer planets are not as cold and lifeless as they once were thought to be. Just like the recent expeditions have shown us Jupiter and Saturn to be vibrant, intricate systems, featuring layered atmospheres, enigmatic cores, and potentially even habitable moons, so too is Neptune becoming an exciting new frontier in planetary science. What makes it particularly pressing, however, is how little direct investigation the planet has thus far had. Voyager 2 is the sole spacecraft to have flown past Neptune, and that flyby lasted only a few hours in 1989. All other knowledge comes from Earth-based telescopes and indirect observation. But even with limited resources, Neptune is providing hints that could transform our knowledge of planetary science. Momentum is finally gathering behind the call for a dedicated Neptune mission. NASA and other space agencies are seriously debating sending orbiters or atmospheric probes down into Neptune's depths to provide direct data on its core, magnetosphere, and enigmatic emissions. These missions would either affirm or debunk the new radical theories being advanced. But urgency is of the essence. With each passing year, Neptune's changing behavior yields more surprises, more puzzling than the last. In many ways, Neptune has gone from being the forgotten ice giant to one of the most compelling bodies in the solar system. Its secrets could answer fundamental questions about how planets form, how magnetic fields evolve, and whether similar bodies across the universe might harbor conditions we've never imagined. As the world's scientific community, and NASA specifically, sets its sights on this mysterious planet, one thing has become more obvious by the day: Neptune is not what we expected. And that knowledge might just upend everything. If you enjoyed this video, be sure to like it and subscribe to our channel. Leave a comment below and tell us, do you believe Neptune is keeping secrets? What do you think of its enigmatic changes? We'd love to hear your opinions. Thanks for watching, and until next time, keep your stars in sight.